All right, so we are looking at slides 9 through 12 today, and this is on logs and exponential functions. So we've got 4 problems we're going to go over to get you ready for the Canvas review on logs and exponentials. So slide 9, the first problem, it says solve log base 5 of 2x plus 1 plus log base 5 of x is equal to log base 5 of 10. All right, so we can combine, if you have 2 logs on one side, the first thing you want to do is combine them to make 1 log. When we solved equations with logs, that's what we always did. And the 1 log will keep the same base. So since I'm combining these 2 logs, they will become 1 log base 5. Okay. And if you remember, because there's a plus in between the logs, that means we multiply the 2x plus 1 and the x. So we multiply 2x plus 1 times x. So we distribute it to both. So we'll get 2x squared plus x, or plus 1x. And that's what goes in the parentheses of my 1 log when I combine them. So plus you multiply. If there had been a minus, then we divided. All right, and then this other side, the right-hand side, is already just 1 log, so we'll leave it. And then if there's a log on both sides, like we have here, then once we are down to 1 log on each side, then you can get rid of the logs and just set the inside pieces equal. 2x squared plus x is equal to 10. And then solve your equation. Now this one is a quadratic, so you can't just subtract and divide like linear equations. So if you get a quadratic equation, go ahead and get everything on the same side, like set it equal to 0. And then remember, we can type that in decimals and find the answers to that quadratic there. So let's do that really quick. So I've actually already typed it in decimals, 2x squared. Oops, it's plus x. Let me fix it. Plus x minus 10. And when you're solving a quadratic in Desmos or solving any equation in Desmos, you're looking for the x-intercepts, the numbers where it crosses the x-axis. Negative 2.5 and 2 would be solutions to this quadratic, but logs, we can't take the log of a negative. So we're actually only going to take that positive answer, positive 2. So the only answer that we're going to get is positive 2. Okay, so that's why when we're looking at our answers, we don't see the negative 2.5 as an answer choice. So we're just going to pick positive 2. All right, so if you want to put a little note there for yourself that if there's a log on both sides, they cancel. Okay, if there had only been a log on one side, that's when we had to switch forms, switch to exponential form and solve. Okay. All right, next one, it just says simplify. There's no variables. Log base 3 of 3. All right, simplify. Log base 3 of 3. You actually type this one straight into Desmos. So let's do that. Okay, remember that log base, to get that, we hit the keypad. Functions, all the way over to miscellaneous, MISC, and then pick the log with the letter A there so that we can type a base in. So the base goes there, log base 3. of 3, that number goes in the parentheses, and it will just tell you the answer. So this one is equal to 1. And this one equals 1. You will have decimals on the EOC. Okay, for this one, the answer is just 1. And I'm going to put a note that we just type in decimals. Okay. All right, next one, solve for x. Log, there's no base here. So if we have a log, this is the note I want you to put on this one, a log with no base means the base is 10. Okay. And in case you see this, a log, it's actually just right, a natural log, remember ln we saw sometimes? ln has a base of e. E was a number, but we just typed e in whenever we use it. All right, so if you ever see one of these things, which we have a log with no base this time, so we're using that. All right, so it says solve for x, log of 2x, in parentheses, subtract 1 is equal to 2, round to the nearest thousandths place. No answer choices this time. So first thing I need to do is isolate the log, right? The parentheses are only around the 2x. They are not around the 2x minus 1. So we are going to add 1 to both sides. Okay, so log of 2x equals 3. So if you look back at the first problem we did today on slide 9, we said if there's a log on one side only, which is what we have here, only a log on the left, then we switch forms. To switch forms, we need the base, which is 10, because there's no base written. And we do base to the exponent equals the inside. Base to the exponent equals the inside part. And then we just do the math. So 10 to the third is 1,000. And then divide by 2. Okay, so x is 500. Okay. All right, and then last one. A city starts with a population of 500,000 people in 2007. Its population declines according to the equation, and they gave us an equation where P is the population, T years later. So T is in years, P of T is population. Population after time. And T is time in years. Remember, E is not a variable, E is a number. We'll type it in the calculator when we get there. Approximately when will the population be 1/2 of the initial amount? So if our initial amount was 500,000, then 1/2 of the initial is 1/2 of 500,000, right? 500,000 divided by 2. So we're trying to find when the population will be approximately 250,000. That's 1/2 of 500,000. And they gave us answer choices. So we use our answer choices to help us here. So what we need to look at is T is time in years after 2007. So for instance, 2010 is 3 years after 2007. So 2010 represents T equals 3. Okay, just by subtracting. 2014 is 7 years after 2007. So that represents T equals 7. All right. If you don't recognize what the number is right away, you just subtract it. All right, 2014 minus 2007 means t equals 7. So like for this one, 2056 minus 2007 is 49. So it's 49 years later. T is 49. And then 2147 is 140 years after 2007. You just subtract them. All right, so since they gave us an equation and they gave us answer choices, we can actually just plug these in and see which one gives us the closest number population to 250,000. So we're going to go to Desmos and type in this equation, and we'll just kind of use the answer choices to help us. All right, remember E is just the letter E, and it represents a number about 2.7. Okay, so let's go to Desmos now. All right, so we're just going to be typing in our answer choices. I'm going to use answer choice A the first time. So 500,000 E, and then as an exponent, it said negative 0.099 times T. So this is where we're going to plug our T values in. So I'm going to start with answer choice A, which was T equals 3. And see, it tells me right here, that would give me 371,000. That is really far from 250,000. So it's probably not answer choice A. So if I want to try answer choice B, I just plug 7 in, because that's when T is 7. Answer choice B is very close. 250,036 is very close. So it's more than likely answer choice B. If you wanted to be sure, you could try the other ones and see that they're very far off. So because B gave me the closest number to 250,000, then B is the answer choice that I'm going to go with. So for this problem, I would say the answer is year 2014, answer choice B. Okay. All right, that is all for this lesson, this Ed puzzle. So now you're just going to be working on the Canvas assignment that goes along with it.